Okay, it's 6 o'clock local time, so we start the MANET meeting. Welcome all. Um, this is the note well, which you should read. Um, Working group chairs have been instructed not to try to reinterpret. Is it not working? Test. Okay. Try again. Welcome to MANET. This is the note well. Um, you should take notice of this. Working group chairs have been instructed not to try to reinterpret what is written here in their own words. So just go read it. Which also holds for the note very well, which is about being nice to each other. It literally said, treated with dignity, decency, and respect on the second bullet. Don't harass people. If you feel that you are being harassed, get in touch with the ombuds team. Meeting tips, where you can find what to do. Resources for IETF one-to-one as a whole. Some specific links for this session. And then our agenda for today. We have 3 presentations. Then we have some room for charter discussion. Before all of that, we will give an update of where we are with the drafts that are out of the working group or still in the working group or might be accepted into the working group. Going back one step, is there anyone who wants to bash the agenda, and is there anyone who is willing to take some notes? Is there anyone in the queue? No. Then we go to draft status. There are these 4 drafts on credit-based flow control that have been with us for a long time. We still have not managed to get them into the editor queue. They're in the stage that they have been, or they are being reviewed by the directorates of the various areas. We still need to respond to a number of those comments. Unfortunately, we have lost, and literally lost, 2 authors of this whole set of drafts. The remaining authors are of the opinion that it's taking far too long. It has taken far too long. They don't have the energy and the time anymore. We understand this. So the chairs have decided to help out. We have divided up the work among ourselves, and we are going to successively address all these area directorate comments. Donald has already made a start with that. Don is probably going to be an editor of at least the classification thing. You want to speak to that?
Sure. Yeah, I've gone through all the comments on the traffic classification, but we have to get the authors to sign off on them, and we're in the process of doing that. And you can, it's all public. What we've got it on Lou Berger's GitHub page. So if you just Google Lou Berger, and you could look at the DLEP extensions. Yeah. Oh, thanks. And and I'm doing that for the traffic classification. Eric has been doing that for the Eric Kinsey has been doing that for the flow control, the credit flow control, and Donald is doing the IP and the Ethernet extensions drafts. So we should have, in short work, we should have new versions out and addressing, at least attempt to address all the outstanding comments from the people to get everything moving again.
Okay. So moving on to active working group drafts, and these are just this morning, just this morning, these have been reactivated. They had expired. We really want to see some more reviews of these before we think we can move to working group last call. These have been around also for a long time as individual drafts. They got accepted into the working group late last year, I think. They're very short drafts. So comment on these drafts if you haven't done it before, and you can even say, yeah, they're fine, but don't stay silent. Then we have two individual drafts that are related to MANET. They have MANET in the title somewhere. I ran into the let's say the leading author of the first one, David Liu from Huawei, yesterday, and he said that they are trying to keeping this draft alive by producing a new revision before it's expired, but they're rethinking the scope. This was presented in San Francisco at IETF 117. There was a fair bit of comment on it, and amongst themselves, the authors are trying to make up their minds what to do with this. At this stage, they did not see the need to present it again in the working group. Christopher Derloff is going to update his draft, or has already done work on this, but not sent it yet. But will also do shortly, if I understood him correctly. I don't want to put you on the spot, Christopher, but if you have something to add to that, feel free. Jim.
Yeah, so Jim Guichard, FutureWay. So I had a couple of comments that I just want to make. So just to make things clear. So on that first slide with those 4 documents, just to make it clear to the working group, I'm ready to go. So, you know, the comments that are there, as far as I understand it, are based off of the last call, the IETF last call. I don't intend to review those documents again. As soon as you tell me they're ready, I'll ship them. And, you know, I don't want to be the bottleneck here. So I don't think there's huge changes to those documents as far as I can see. Also, I've been keeping to the assumption that you wanted me to put all 4 of the documents through all in one go. If you tell me, no, Jim, it's okay, you know, you can put through this one through now separately, or what, I'm happy to do that. It's just that they're sat there. There are comments that need to be, you know, updated, and I can't do anything until you do that, because they've got to be addressed, whether it be after IESG evaluation or not. So just so you know, I'm ready. So just give them to me. The other documents that you talked about, the other work in the next slide, you know, my comment here would be, are you utilizing the directorate? Because, you know, if nobody in the working group has the time to do those reviews that you're looking for, you know, I don't want them just sat there in the working group. Let's get the directorate to, you know, step up and actually review those documents. And if the comments coming back from that are okay, let's get those moving. So I'm kind of keen to unblock this thing and let's get going so we can then talk about the recharter and the new work that you guys want to do. So I just wanted to make it clear.
Thank you. Yes, the ball is in our court. We have to address the comments on these credit-based flow control drafts, the 4. As far as these drafts by Henning Rogge are concerned, Don has commented on one of them. I think between the previous meeting and this one, and because these were refreshed this morning, I did not check yet whether those comments were addressed in the new version. I'm still to do that. Myself, I want to at least on short notice comment on the radio quality one. I think I have commented way back when on the channel utilization one. But yeah, I will dig that up and repeat what I had to say about it. Christopher's in the queue. Go ahead.
You summarized my position entirely correctly.
Thank you. Then we need to bring up a new slide deck. Fred, are you ready to present your slides?
Are you hearing me?
Yes.
Okay, yes, I can present. This was originally intended to be a longer presentation, but due to the current business climate that we're facing, I requested a reduced time slot to just cover the high points. So we'll just take 5 minutes to go through these materials. Next chart, thanks. So in terms of a problem statement and solution summary, MANET routers support multi-hop forwarding within their local service areas. MANET routers may sometimes encounter intermittent or continuous internet gateway connectivity. And during that time, it would be great if they could connect up to the global internet. So MANET routers will use a multi-link local address locally within the MANET, but they'll auto-configure global unique addresses for internetworking purposes. So MANET router auto-configuration services and internet working forwardings are based on a new architectural layer known as the adaptation layer. And if you see the diagram on the right, you see the protocol stack layer there, where the adaptation layer is a new layer in the architecture between the network layer and the data link layer. And that adaptation layer is manifested by automatic extended route optimization and the overlay multi-link network interface to support all the necessary functions. So looking at the diagrams on the right here, we see 3 different use cases for MANET internetworking. The first in the upper right, you see 2 nodes within a single MANET doing multi-hop forwarding over the MANET from peer-to-peer. The lower left, you see a node within a mobile ad hoc network connecting out to a node in the internet using a gateway that's shown in green here as a connectivity point to the global public internet. And then on the right, you see a node in the internet being able to call into a node in a MANET, again using this gateway. And this is all supported through these Arrow and Omni multi-link networking capabilities. Next chart. So in terms of next steps, each MANET router configures an Omni interface and assigns them multi-link local address to the Omni interface. The MANET routers use arrow control messaging to invoke DHCPv6 auto configuration services and obtain globally unique addresses from internet gateways. The Omni interface then supports IPv6 encapsulation for internet forwarding using the global unique addresses for peer-to-peer communications. And the MANET routers use the Arrow and Omni capabilities to traverse internet gateways and reach correspondence in both the internet and other MANETs. So in the diagram on the right, you now see a use case where we have two separate MANETs that are using the global public internet as transit. We have a node within a first MANET being able to call out across the internet through internet gateways to access the peer that's in the separate MANET. So what I've now shown is internetworking use cases for connecting MANETs to the global public internet. And the final question was whether we want to take these documents on as working group items. That's the end of my presentation.
Thank you. Christopher, you are still in the queue or again in the queue? Do you want to comment on this?
Sorry, no, I want to set. Sorry, I forgot to unset myself.
Okay.
Hello, Rick Taylor.
Rick.
Do we not already have technology to do this within the IETF? I mean, I could build this using SRv6. I'm not sure I completely understand why the MANET has to have a completely independent IP addressing scheme and some sort of I can understand what you're doing. I don't understand why, I think is my question.
It's to bring MANETs into the internet and connect MANETs to the internet using the Arrow and Omni interface for internetworking and for auto configuration purposes. You may have been around, Rick. I don't know if you were around back when we had the AutoConf working group.
Yeah, I caught the tail end of it.
Okay.
I will admit it went on a while.
Right. So this is kind of picking up where the AutoConf left off. And really this work has been in progress since the about Y2K timeframe. It's been going on for about 20 some years. And we're now at the point of maturation with these drafts that we can now provide an auto configuration and networking service for connecting MANETs to the global public internet. These technologies do something that nothing else can do.
But that is built on the assumption that the MANET has a completely opaque and independent addressing scheme from the public internet. And I wonder in the days of IPv6 whether that's the model we follow these days. And yeah.
So with IPv6, Rick, when you have a MANET that's completely separate from the internet, has no connection points to the internet, it needs to have some way to configure IPv6 addresses that it can use internally to support the multi-hop forwarding with the MANET.
Sure.
And that's based on this new address type that I'm calling a multi-link local address, or an MLA. The multi-link local addresses can be special purpose IPv6 addresses that are guaranteed to be unique through the birthday paradox of uniquely assigning an address that is either randomly chosen or assigned through an address attestation service. But they're not necessarily routable on the global internet. And so for that, when you do connect a MANET to the global public internet, you need to be able to get global unique addresses that are relative to that attachment point to the global public internet. So there's two different address types, the multi-link local address that can be used within an isolated MANET, and the globally unique addresses that you get when you connect the MANET up to the internet.
Yeah, I'd love someone who knows more about IPv6 ops than me to get a good review of this, because I can understand over the 25 years since this work started off, I think some of these problems have been solved, and the idea of an entirely independent IPv6, IPv6 like MANET addressing subdomain, using a variant of Slack or what DHCPv6 to hand out something which is just not routable. it kind of smacks of DHCPv4. I mean, well, IPv4 in general, and we're bringing back NATs again. And I don't know. I have no horse in this race. It's just one of those. I get what you're doing. I just personally don't get why. But thank you for answering. I need to go and read this draft, I think is the answer.
Right.
Thank you.
And that may hold for more persons in this room, myself included. But in the interest of time, further technical comments that you may have, please take them to the list. You were referencing the AutoConf working group, and the AutoConf working group was split off from the MANET working group because at the time the IASG felt that this was not a routing area topic, and the stuff that AutoConf was dealing with was not a routing area topic, and therefore had to happen in int area in a separate working group. Here the picture may be a bit more blurred, including routing and non-routing stuff, the address configuration. But in any case, I don't think we can take this up as a working group item before we recharter. But the point of having this presentation and at least the next one now in this meeting is to see if these are subjects that we should add to the draft charter that we already have. So in that sense, this is something to get familiarized with and then see if you feel that it would fit in a new charter, and whether and to gauge whether there would be people to actually work on this. With that, I would like to go to the next presentation by Roland Bless, and I will bring up the slides.
Yeah,
Floor is yours.
I'm Roland. Yeah, thanks for having me here. So last year I was presenting a routing area working group, and Julius Kowalczyk was at the mic and said, well, we have seen peer-to-peer routing in MANET for a while, and yeah, maybe come over to MANET. So yeah, basically I'm just giving a brief presentation of Kira, which stands for Academia Directed ID-based routing architecture, and I refer to as being a scalable zero-touch routing architecture. Yeah, next slide. Do I have control? Sorry. Okay, so the original goals of Kira is to provide resilient control plane connectivity in order to guarantee a robust network operation. We need that for various kinds of control, be it SDN, NFV, virtual infrastructure management, AI-based control, what have you. So we try to guarantee the controllability of every network device, and therefore, if you want to have this, let's say, resilient control plane fabric, it needs to be implemented in every device, and therefore it's useful to be an IETF standard. So zero touch means no manual configuration, and in addition, you don't have any dependencies. Just the link layer connectivity needs to be there in order for it to work. There are some solutions out there, sure, but they are either not scalable, they are not fully zero touch, or they are topology specific for data center, for example. So Kira was not designed for mobile ad hoc networks. Actually, it was not yet optimized for them, but it's zero touch and ID based. So next slide. So what Kira basically provides is given some link layer topology. Next slide, please. It provides connectivity on top of that. So as I said, for control planes, it provides just the connectivity between all the resources. So you can get back to any resource you want. Next. So on top of that, you typically run your whatever control applications. Could be SDN controller, could be whatever 5G, 6G, SBA entities, a Kubernetes controller, PCE, what have you. So they will do their own control connections and protocols. We are just providing the connectivity. Next slide. So what is different now with respect to other routing protocols? Kira puts, let's say, connectivity first and route efficiency second. Therefore, it's not directly suited for data planes. We're working on that, but right now, let's put it like this, that we have a separate data plane routing protocol like OSPF or ISIS, what have you, but you can go to the boxes and configure the necessary information like area information, router IDs, assign IP addresses, what have you, using the connectivity that Kira provides. Next slide. So one use case is, for example, to use Kira for the 6G control plane, which also includes non-terrestrial networks like drones, satellites, and so on. So they are dynamic mobile. There's a use case also for Kira in that sense that you want to have all the resources that belong to your infrastructure basically tied together by the same connectivity. We also envision nomadic networks, which are autonomous and also need a self-organizing control plane because there aren't, at least for certain periods of time, there aren't any infrastructure elements reachable. And also scalability is an issue, as you may know, there are millions of base stations sometimes just for a single provider, like in China. Next slide. So some features of Kira. It is since Kademlia is in its name, Kademlia is used as ID-based overlay, which uses the XOR metric as metric and as distance, so to say, in the number space. We use 112-bit node IDs, and if you're familiar with the research from more than 10 years ago, there was an approach like virtual ring routing, which also had a similar idea, but it's actually less efficient than Kira. We have small routing tables, so they are scaling logarithmically with the number of nodes, which makes it scalable, but that implies stretch naturally. So you necessarily or cannot always get shortest path routes to your destination. We nevertheless care about efficiency, so we use proximity neighbor selection and proximity routing in order to get still efficient routes. It has more or less two mechanisms. One is some initial path discovery. So you can discover using a first path, which may be longer, connectivity to any node, and then get a more efficient later path that you can use for further communication in case you are able to afford that state. For dynamics, and that's also a unique feature of Kira, we have special path rediscovery mechanism with lag early approaches like virtual ring routing. Nice property is it's loop-free even during convergence. We achieve that by using source routing for the routing protocol itself, but source routing is inefficient for small messages or longer paths. So in order to be efficient for data packets, we use a path ID-based forwarding, which is a little bit similar like label switching, but we can actually pre-compute path IDs for certain set of nodes. It is multipath capable, and since we only have very few routing entries, we can afford having multiple paths to the same destination. And we can also provide additional service on top, like key value store for simple naming services, and also topology discovery mechanisms. Next slide, please. So the architecture is roughly like this. We have a routing tier that tries to find the connectivity using source routing. Below that, as just explained, we have the forwarding tier that uses path ID-based forwarding. And we can also have additional services on top of, let's say, the routing tier that makes use of the structure. For example, the routing table information that we have, and for example, the Kelly topology discovery is very efficient. We only need to ask 4% of the nodes in order to get the full topology. And this is really fast, even for 100,000 nodes. And yeah, it's all based on IPv6. So we are forwarding IPv6 packets, and the R2CAT, well, the routing protocol itself also uses IPv6 between the directly adjacent nodes. Next slide. So I tried to, so that's something that we recently tried, is how does it work out of the box for MANETs? So I'm not well versed in that research, but this is a very simple scenario where we have 1,000 square meters, 100 nodes, random waypoint mobility model, and speeds between 1 and 10 meter per second. And yeah, just without any, let's say, capability of detecting whether the links are there or not, I used yeah, these kind of hello, min, and max intervals in order to detect whether there's connectivity or not. And as you can see, it's barely, it's nearly in the range of other MANET protocols with respect to the delivery ratio, around 95 or 94%. So this has no optimizations, so still optimizations may be possible. It's just out of the box. Next slide. Yeah. So stretch-wise, Julius was very skeptical about the stretch, and as you can see, the stretch is very low here. So it's I mean, stretch of 1 means shortest path route, but we are not very far from that, and this is shown for the first packets. And also you can see that the stretch for the later packets is a little bit better. The overhead not optimized is just like it is, 100 messages per second. I think there's room for improvement. Next slide. How does it work in other topologies? These are fixed network topologies with 10,000 of nodes, and you can see that the stretch is even in some cases or many cases better than Ripple in the ACP mode that uses that is used in Anima. So we can, be it, let's say, fat tree or random topologies, power law graphs, or even the internet, has reasonable stretch values. Next slide. Yeah, so I'm looking for support. So there's a draft out there that is now, let's say, at a level where you can start implementing it. Please provide feedback. It's mainly submitted to the routing area working group. We have running code, so I hacked some stuff at the hackathon. Currently, we have a native routing daemon for Linux, which provides zero-touch IPv6 connectivity. The forwarding tier is realized using NF tables, so it's no special, let's say, new format that you need also. We have an alternative eBPF implementation that is nearly complete, but needs more testing. And I really want more IETF expertise. So there's a site meeting set up for tomorrow evening at 7 in that small Wicklow meeting room 4, or remotely if you want. So I will be, the agenda is that I give another intro for Kira, how it works a little bit, then you can ask questions and we can find out whether there are possibilities for future collaboration. Yeah, thanks.
Thank you. Any questions, comments? Only Roland Bless is in the queue.
I wanted to ask for the slides. So slides control is maybe the problem.
Oh, okay.
No, I asked for the slide control, but worked out. Yeah, that's the problem when I present that. no feedback. Guys, if you think this is worth pursuing, then please.
I'll jump to the mic. Rick Taylor, I think this is really cool. I think this is full of great technology. I'm a big fan of Kademlia, I have been for years. I'm a big fan of DHTs as a way of building ad hoc networks. I've never spent enough time to work out whether it's possible, and it looks like you have. Lots of cool tech. I think it's great. I'm not offering to help, but I wish you all the luck with this.
Yeah,
this looks really cool.
Yeah. So that's one of the things that, I mean, I was not really directly, let's say, involved in the research that my colleagues did at that time, but I know the pitfalls and the other stuff. So I tried really to put the best of my knowledge together in order to get a still efficient routing. And seems like it's working quite nicely.
Yeah. Unfortunately, Julius doesn't seem to be present at the moment.
Okay, thank you. So I'm here all week.
So yes, we will have some offline discussion, I think. So Donald, are you? Yes. Yes. Thank you. Do I need to do something? Okay.
It's just a mouse.
Hi there. I'm Donald Eastlake, unaffiliated. I'm going to talk about the Babel writing protocol for use in 802.11 mesh. 802.11 is Wi-Fi, and maybe this doesn't work. Next slide, please. Is it turned on? That would be a feature. Oh, maybe it works better. Works better if it's turned on. Let's see. There we go. Yeah. Okay. So anyway, this is what I'm going to talk about. The subjects here. So it's Babel is a distance vector, kind of like RIP, except it's got loop avoidance, so it doesn't ever count to infinity or do that sort of thing. And if you do that naively, then you can get starvation, but it has starvation avoidance on top of that. So it reacts faster to topology changes and basically RIP based, but has the solutions to the problems with that. It's been proven to be very effective, particularly in networks with links of variable quality, like radio links and mixed networks and things like that. Well, okay, it's turned on.
Oh, you have to be on the screen.
Oh.
It's a mouse.
Ah.
You can't go and do other ones.
All right. Okay. So it's there's this standard now in RFC 8966. Did well, though it's a while ago, in the various battle mesh in Europe. There's open sources, Wikipedia article, and there's a technical paper at the bottom which gives an in-depth view. That one refers to the previous RFC 6126, which was a experimental RFC, now standards track. The differences aren't that large, but it gives much more detail. So the original idea of 802.11 mesh on the other side was to do wireless backhaul so that access points could talk to each other and get back to a wired infrastructure. But it was fairly soon generalized into really a peer-to-peer mesh where any of the mesh stations can be access points if they wish to be, and the whole thing sort of looks like a link to the outside. So these mesh stations in Wi-Fi, they all send a mesh ID, sort of like an SSID, but different. And there's a path selection protocol and link, a path metric. And if the stations match, they can peer together and form a mesh. And they are pairwise keying, and there's also group keying for each station to the ones that it can see. And as I say, it appears to be a layer 2 link to the outside world. In the most general case, a unicast packet has 6 addresses: the actual source, the mesh entry, the transmitter, the receiver, the mesh exit, and the destination. I'm going along pretty quick here, but if somebody has a question, wants to interrupt, whatever. So the actual connection between a mesh station and outside network is called a mesh gate. So this shows one with 3. So you might say, well, what happens about loops? And the answer is, this is all in the 802 world, so it's assumed that the spanning tree or something equally good is, based on that, is running in the outside network. So that solves that. And if you're interested in how multicast broadcast works and things like that, multicast is the that the stations sort of send to everybody who can hear them, and the frames all have serial numbers, and they keep track of what they've gotten recently. So it basically floods and prunes, and stuff gets everywhere. You say it uses a patch selection protocol and link metric, and it was always realized that different meshes with different densities and station capabilities and number of radios per station and who knows what might require different path selection protocols and metrics. So it was designed from the beginning so you could have different ones, and you can even assign your own vendor, quote, vendor specific. And so the IETF can fabricate new ones using the IANA OUI if we feel like doing that. There's only one specified in the standard, which is called Hybrid Wireless Mesh Protocol. And it's based on AODV with some tree-based additions. And there were two early in the development of Wi-Fi mesh. The other one's called Radio Aware OLSR. There's always tremendous pressure to simplify things going through the standards process, and it got pruned, shall we say. Like everything that comes along in Wi-Fi, the mesh also has some power save for when stations can sleep and congestion management stuff, and a few other gizmos. So, and there's no longer a separate document. It's been rolled into the base standard like they do periodically. Current base standard is 2020. There's a new one close to coming out, but doesn't matter. So you can go to the Get 802 standards page there and get your own copy of this massive document, which has the mesh scattered around. Well, there is some sections that are pretty, but there's our mesh provisions throughout. The Wikipedia article lists some implementations. It was at least one point in Linux and the BSD, and an early version of the 11S draft was used in the One Laptop per Child, a not terribly successful project. But and there's lots of mesh products available for Wi-Fi that say they're mesh, but as far as I'm aware, none of these actually use the standard mesh in there. And my purely personal opinion is that it hasn't been very successful for two reasons. At the time, there was no way in the 802.11 standard to really handle multiple radios per station. And if you don't care much about performance, you can have a mesh with one radio per station. But given the interference and stuff, you really, to get decent performance in a mesh, you need multiple radios. And secondly, I think that for many cases, the routing protocol they chose wasn't the best. So that has been essentially solved. There's 802.11be, which is official name is ultra high throughput, and it has defined a new thing, sort of above a station, although really they'll be physically all grouped together, called a multi-link device. But what it really kind of means mostly is a multi-radio device, despite that name. There's multi-link APs and multi-link non-AP stations, and although it can be that the links are different sub-channels within the same piece of spectrum. So in some sense, the multiple radio problem is solved, and I think Babel would be a very useful addition to Wi-Fi mesh to get a better routing. So what exactly would you do if you were going to do Babel for 802.11 mesh, say in the MANET working group? The big thing, of course, is to write an RFC that specifies how to use the Babel routing method inside 802.11 mesh. And it would be a path selection protocol. We'd fabricate an ID for that. You could also specify how to use the Babel default link metrics in 802.11. Conceivably, you could use that with some other 802.11 thing. And down at the way at the bottom in small type, if you got all that done and stuff, you could define how to use the standard 802.11 link metric in Babel, which is called the airtime metric, airtime link metric. So I think the importance is proportional to the order and the size of the type here. So it would be basically easier to have Babel working inside 802.11 mesh than it has been to develop the IP protocol, because you don't need to carry IP addresses, protocol prefixes, and links. You just use sets of MAC addresses. You don't need to have a separate router ID, because the MAC address can serve as a router ID just fine. You don't need to worry about security. There are two other RFCs, standard spec RFCs, that define security for Babel, one of which provides just authentication, the other provides authentication and confidentiality. because 802.11 has all its own security. You know, I mean, the wireless 802.11 links sort of default to, you know, line speed encryption and so forth. So Babel is very flexible on its link metric, so it should work fine with the existing airtime metric. So we have explicit permission to do this. I gave a presentation to 802.11, which is the first pointer there, and they have sent a liaison to us in which, of course, they don't want to say it's good or bad, but they say we have no objection. And in fact, they're very cooperative. And I'm sure, for example, if somehow it turned out we needed another code point in some other 802.11 code space to do this efficiently, I have personal confidence that we would be able to get that allocated. They do have an assigned number authority, but it's just inside 802.11. So you'd have to get the 802.11 working group to agree to it. So somebody needs to write a draft. Or, and of course, it would also be useful for it to be in charter, but maybe I should have put that on the slide too. Anyway, that's about it.
Thank you, Donald. Oh, Lou, go ahead. Sorry for, are you referring to a specific slide? And I'll bring the deck.
No, I'm just, Lou Berger. I'm trying to understand what you're expecting us to do here, other than saying, hey, we could do this. Are you saying anything?
Well, one thing I'm saying is that I support the text in the draft new charter that says that Babel maintenance and development can be done in this working group.
Okay.
Yeah. And actually,
so
I mean,
is it Babel or 802.11 with the specific version of Babel? I mean,
it's Babel. I mean, the way the routing protocol works would be the same.
So if you could bring back maybe this.
But the thing is, you have to say how to encode the Babel mess.
I'm joining in the conversation. Sorry, Don, I'm not
Excellent.
helping.
Right. Go ahead.
I believe what Don is proposing is that in an updated charter, this working group could produce what is effectively a profile of Babel suitable for the 802.11 mesh environment. So using possibly the airtime metric, but that's a nice to have, but definitely dealing with MAC addresses, not IP addresses. And then should just slot in, having looked at having looked at S ages ago, it should just slot in.
Babel has a address type, data element, and you would have to allocate a new address type for MAC addresses.
So as I read the slide,
yes,
if you bring the slide up, that's great. If you can't, and you can just tell me I'm misreading it. But as I read the slide, it said that we could do
which one?
The one with the second to last one, I think it was.
Very near the end.
Yeah. The implication there is we could do anything we want on, no, the one that said, this one. So I think what's not clear, what such activity is here, and what the scope of what we might do related to what another SDO has defined. And I think that's it's not clear how far you're opening the door here. And so I think we should be really careful in anything we do related to another SDO's work to stay within our swim lane and not repeat some of the things we've done in the past of doing work on another SDO's protocol, which goes well beyond what they may have envisioned or really into their domain. If we're modifying their protocol, that work should be in 802.11, not.
Well, we basically have to figure out how to encode the Babel routing messages inside 802.11 control frames. And so it may end up being helpful in this regard that I was chair of 802.11 mesh for half of its existence. And I'm kind of thinking I might write this draft, but go ahead.
No. Rick, we have two cards in the queue.
Then why not do it in 802.11?
because there's no energy, that nobody cares much about mesh right now. The big locus of effort now is 802.11bn, whose official name is ultra high reliability. And of the 300 and some members of 802.11, when you go to look at one of their parallel sessions, 285 or so approximately, or 280 or in that. So there are other activities happening there. So, I mean, I don't know if you're aware of the process of getting a new task group chartered and things for an amendment to 802.11.
I understand. I think I know it a little bit, not a lot. My suggestion is to be very careful in any revised charter language to be very narrow scoped into things that are appropriate to be doing in the IETF and aren't doing things that are appropriate in another SDL.
Okay.
Point taken. Stu.
Real quick question, Don. Is there anything in all this that wouldn't play well with the somewhat special things that are done in 802.11h, Halo?
I don't think so. I guess H is the low frequency, the higher range stuff.
Yeah, the low duty cycle 915 megahertz stuff.
Yeah, well, I mean,
that's AH.
Yeah, well, I'm not going to say anything about what exactly performance would be like and so on and so forth, but I don't believe there's anything inherently different about that communication except that for timing and frequency and distance and all that kind of stuff. But it's all basically 802.11 is somewhat consistent.
I'll be quick.
Very quick, Rick.
I'll be
because we're running
quick.
out of time.
Yeah. To address Lou's comment about is this relevant within this SDO rather than IEEE, I believe, and Don can correct me on this, that 802.11s as originally written very much borrowed AODV from this working group. From this working group, and was engineered such that, as you said, path selection algorithms can be plugged in, and it would make sense that this working group proposed or worked on yet another plug-in MANET routing protocol to work in this environment. So I think it's valid and I'd support it.
Thank you.
Thanks. Which leaves us with just a bit of time to go over the draft charter text again, but that's not a real disaster because we discussed this somewhat longer in Vancouver already. And actually everything that has happened since is that I've incorporated the changes that were proposed by Julius Grobacek. Meaning that it now looks like this. Here, this is a general introduction to what this working group is about. There have been some minor changes here. This is mostly old charter text still. That has not changed. This is the DLIP specifics part where I have again applied a few of the suggested changes from Julius. This we spent some time on in the Vancouver meeting. And I'm still personally uncertain whether there will be any energy in the working group to pursue this. And I think we need at least more justification for why we would be wanting to work on this. And then, we need at least some people wanting to go do the work. Rick.
Question for the chairs concerning AODVV2. So I've recently spoken to two of the authors on the MANET working group draft of AODVV2. and neither of them have had any communication with Charlie Perkins for 4-ish years. Have you managed to speak to Charlie about AODVV2 and it's off as an individual draft in Dispatch or somewhere at the moment? Is the intention, I mean, I would support working on it, but has anyone spoken to Charlie about this, or is this going to disappear into the void?
Charlie has presented this when? Was it Brisbane or before? Okay. So
I've exchanged email with him.
Good.
You know, I encouraged him to produce a draft. I'm not sure I know all the people in communications paths and things involved, because it seemed like having something, you know, upgraded to the current draft, just with formatting standards and things like that, would be a useful starting place or thing to work from. And you know, he's willing to do more work on the document,
Great.
but is not in a position where he can do implementation. That
Great.
seems to be the status.
It was in a polite way. I was asking, does Charlie still have the energy to work on this, and is he still willing to do it?
And I think that, yes, he indicated that at the time.
Brilliant. Cool.
I think the consensus was, though, that we don't have a lot anybody really driving this. Like, you know, we have a few people willing to write drafts, but there was nobody that said they were going to prototype it or use it. So it's not strong support right now.
Fred, please be very brief because we have less than 4 minutes left.
Yeah, I can be brief. I just wanted to mention that the draft charter text does not talk about connecting mayonnaise up to the internet. Internetworking for mayonnaise, I think, is a very important consideration, especially since we're in the Internet Engineering Task Force. And so a means for connecting the mayonnaise up to the internet and for internetworking with mayonnaise, I think, is something that needs to come into the charter.
Would you be willing to provide a paragraph of text for that?
I can do that.
Okay, thank you. Okay, this is multicast. We've discussed this as well. Changed some of the wording, added the part about reverse path forwarding on Julius's request. I agree with it, by the way. This is not interesting. Yeah, there's something there about the IPPM. I think that's been overcome by events, but and this is the list of potential work items, a bit rationalized since last time. Yeah, should be enough to keep us busy for a while. If there are people to pick up some of these or all of these, hopefully. And now we have less than 2 minutes left. So any final comments on this by anyone online or in the room?
Of course, you can all comment on the mailing list.
Yeah, that's what I was going to say. And there will be follow-up on the DLEP draft shortly on the mailing list as well.
Yes. I would also almost say it goes without saying that there's the mailing list for everything that falls off the edge of a 1-hour meeting. So thank you all for attending, either in person or remotely. Meeting adjourned.
Yes, thank you all.